morning, students. In today's class, I'm going to explain you about rate law and about order. And do remember, in the chapter called Chemical Kinetics, one of the most important term is order, which comes mostly every year. Okay, in our last class in Chemical Kinetics, we learn about rate of reaction, then we learn about factors on which rate of reaction depends, then we learn about your activation energy, threshold energy. In today's class, we are going to learn about rate law and about order of reaction. So now I'm about to explain you is about rate law. Okay, so I'll show you this statement afterwards. First, you can see out here. Let us consider a reaction where A and B gives you product, suppose C and D. These are the coefficients known by the name stoichiometric coefficient of the reactant is small a and B. Stoichiometric coefficient of product is C and D. Now I need to determine the rate law from here. So always remember, rate law states that rate of a chemical reaction is directly proportional to the product of molar concentration, represented by square bracket, of the reactants, that is A and B out here, raised to the power of their stoichiometric coefficient, that is small a and B. And rate law does not depend upon product, but it depends upon reactant concentration. So I repeat the law again. If this is a reaction where I have to determine the rate law, so the answer will be rate of a reaction is directly proportional to the product of molar concentration of the reactants raised to the power of their stoichiometric coefficient, that is small a and B. And the square box indicates concentration. And whenever we open proportionality symbol, a constant has to come. Okay, so when you open proportionality symbol, a constant will come, and that we put out here is K. And this K is known by the name rate constant. Rate of reaction is represented by small r, rate constant by K, and this A and B are the concentration of the reactant AB, and this is the coefficient. And this expression which we got from rate law is called rate equation. So now see out there. So what is the definition of rate law? Rate of a chemical reaction is directly proportional to the product of molar concentration of the reactants raised to the power of the stoichiometric coefficient. Okay, so if this is a reaction, this will be the expression of rate law for it. And when you open proportionality sign to equal to sign, a constant will come K, and this K is called rate constant, and overall this is known by the name rate equation. So this is all about rate law. Now we will see order, a very important part of ISC in this chapter. Order is represented by the symbol small n. Now let us see what is order. Again, let us consider the same reaction here, and this will be the rate law of it, and this is the rate equation. Now in the rate equation, how to find the order? Order is represented by the symbol small n. You just have to sum up the power of the reactant. So when you sum up the power, you get A plus B. So for this reaction, order will be A plus B. Okay, for this particular reaction, order will be A plus B. By summing up the power of the reactant, you get the value of order. So what is the definition of order then? It is defined as sum of the powers to which molar concentration of the reactants are raised in the rate equation. I repeat again, order is defined as sum of the powers to which molar concentration of the reactants are raised in the rate equation, and order is taken as experimental value. Okay, order is an experimental value. Now you can see in this slide, it is the sum of the power to which molar concentration of the reactants are raised in the rate equation. Just now I give you the definition, and if this is the equation, then this will be the rate law, and this will be the rate equation. And when you sum up the powers, power AB, that will give you the value of what? Order. And do remember, students, order is an experimental value. So this is all about order. Now we are going to see is the type of order of reaction. Okay, there are different types of order of reaction, like zero order reaction, first order, second order, third order. So if any question comes this way, you have to give, okay, state the order of reaction. So you have to say there are 4 orders of reaction: 0 order, first order, second order, and third order. But do remember, order can also be in fraction, but does not come under the type. Order can also be in fraction, but it does not come under the type. The types are 0, first, second, and third. Now I am going to explain all of this one by one. So let us go first of all with 0 order reaction, then first order, then second order, then third order. Okay, order can also be in fraction but does not come under the type. Okay, to make you understand these 4 different order of reaction, I am taking a single reaction. Let A gives you product be a 0 order reaction. I am considering this as a 0 order reaction. So if I consider this as a 0 order reaction, what will be the rate equation? R equal to K, concentration of the reactant. R is rate of reaction, this K is rate constant, concentration of the reactant. Who is the reactant here? A. And since I am considering it as which order reaction? 0 order reaction, then the power should be kept 0. And this is the expression for 0 order reaction. Okay, and you know that anything to the power 0 is how much? 1. So therefore rate equation will become like this: R is equals to K, and this will be the expression for 0 order reaction. If I consider the same reaction, A gives you product as now first order reaction, then the rate law will be like this: R is equals to K, again rate of reaction, rate constant, concentration of the reactant is here is A, power will be 1 because we have consider it as which order reaction? First order reaction, and this will be the expression of the rate equation. Similarly, if I consider again the same reaction as second order reaction, let A gives you product is a which order reaction now? Second order reaction. Okay, then the rate law will be R is equals to K, concentration of the reactant. Who is the reactant here? A. And since we are saying second order reaction, so the power will be 2. So this will be the expression for second order, first order, 0 order so far. Now again, if I consider the same reaction as the third order reaction, then the expression of rate law will be R is equals to K, rate of reaction, rate constant, concentration of the reactant. Who is the reactant here again? A. And since it is a third order reaction, the power will be 3. Students, never get confused with the coefficient of A which in the supposition part, because if you see the coefficient is 1, 1, 1, 1 everywhere, but that is theoretical way. In experimental way, no matter it is 1 out here, but since I have considered it as 0 order, so I will put 0. I have considered first order, so I will put 1. I have considered second order, so I put 2. I have considered third order, so I will put here 3. Now, how to define these 4 orders of reaction? So let us see from here. Define third order reaction. So you have to say like this: these are those reaction in which rate of reaction depends upon 3 concentration term of the reactant. Define second order reaction. These are those reaction in which rate of reaction depends upon 2 concentration term of the reactant. Define first order reaction. These are those reaction in which rate of reaction depends upon 1 concentration term of the reactant. Define 0 order reaction. These are those reaction in which rate of reaction does not depend upon the concentration of the reactant. Why? Because here is no A in the expression. So I repeat again, third order reactions are those reactions in which rate of reaction depends upon 3 concentration term of the reactant. Second order reactions are those reactions in which rate of reaction depends upon 2 concentration term of the reactant. First order reactions are those reactions in which rate of reaction depends upon 1 concentration term of the reactant. And 0 order reaction are those reactions in which rate of reaction does not depend upon concentration of the reactant, because here is no A in the expression. And does not depend means the rate of 0 order reaction is independent of the concentration of the reactant, where others are dependent. Whether others are what? Dependent. Only the rate of 0 order is independent of the concentration of the reactant. So from here observative question can be made. Name the order of reaction whose rate of reaction does not depend upon concentration term of the reactant. Does not depend means whose rate is independent of the concentration of the reactant. At that time, the answer will be zero order reaction. Okay, now I'm going to explain you here. So, as I said I have explained you the 4 types of order of reaction. So, first I like to go with zero order reaction. You can see the definition here. These are those reactions in which rate of reaction does not depend upon concentration term of the reactant. And since I have considered it as zero order, so power will be 0, R is equals to K, power will be 0, and 0 means zero order reaction. First order reaction, these are those reactions in which rate of reaction depends upon one concentration term of the reactant. So if this is the reaction, student, the rate law will be like this: R is equals to K, A to the power of 1 by 1, because it is first order, so the order will be 1. Now second order reaction, these are those reactions in which rate of reaction depends upon 2 concentration term of the reactant. So if I consider again the same reaction as your second order reaction, you have to put power 2 in the expression of rate law, and the order will be 2. And third order reaction, these are those reactions in which rate of reaction depends upon 3 concentration term of the reactant. If I consider the same reaction as third order reaction, then in the rate law the power will be 3 and order will be what? 3. But please student, do not mark these definitions. This is a very simple way for you to remember all this definition. I repeat for the last time. Define third, second, first and zero order reaction. Rate which depends upon 3 concentration term of the reactant is third order. The rate of reaction which depends upon 2 concentration term of the reactant is second order. The rate in which it depends upon 1 concentration term of the reactant is first order. The rate which does not depend upon concentration of the reactant, that is independent, is zero order. And zero order are those reactions in which rate does not depend upon concentration, means rate is independent of the concentration, so the answer will be zero order. So here is one observative question for you. Name the order of reaction which is independent of the concentration term of the reactant. Okay, that means which does not depend upon concentration of the reactants. And this question can be asked in another way. Name the order of reaction whose rate is uniform with the change in concentration of the reactant. Uniform means will not change. No matter how much you increase the concentration, the rate remains same. Second part, both question is same, in different way it has been asked. For answer for both is zero order reaction, because zero order reaction does not depend upon concentration of the reactant, means no matter how much you change the concentration of the reactant, the rate will remain uniform, same, and the answer is zero order reaction. Now you can see this graph out here. Identify the order of reactions. If you see out here, along x-axis we have concentration, along y-axis we have rate. So no matter how much you increase the concentration, students, if the rate remains same throughout, no change, then that is zero order reaction. So for this question, 4 options are given, whether it's a zero order, first order, second order, third order reaction, and the answer for this is zero order reaction. Why? Because you are changing the concentration, but the rate remains unaffected. It is constant. It goes uniform. So the answer is zero order reaction. Okay. Now this important note you have to understand. Okay, and it is going to help you in objective question in your ISC. So before I explain you this again, I like to show you something out here. All of you focus out here now. Okay. Suppose let A gives product is a third order reaction. I am supposing third order reaction. Then what will be the rate law? R is equals to K, rate of reaction, rate constant, concentration of the reactant. Who is the reactant here? A. And since I am considering it as third order reaction, so the power will be what? 3. Clear? Now what if I double the concentration of the reactant? What if I double the concentration of the reactant? From A I am making it 2A. I repeat again, I am doubling the concentration of the reactant. That means I am making it 2 times, from A to 2A. Then what will be the effect on rate? R is equals to K, A to the power of 3. Only number I have not written here. So here 2 is present. So 2 cube is how much? 2 cube means 2 into 2 into 2 means how much? 8. So therefore, whenever you double the concentration of the reactant, rate becomes 8 times. and that is which order reaction? Third order reaction. So when you double the concentration of the reactant, if the rate become 8 times, that becomes which order? Third order reaction. So in the first point, what I have written out here now? The order of reaction whose rate becomes 8 times, when the concentration of the reactant increased by 2 times, then the answer will be third order reaction. How? You can see here again, concentration is been doubled, rate became 8 times, so it will be which order reaction from now on? Third order. And how to remember? Double means 2 times, the rate becomes how much time? 8 time, and 8 actually means 2 cube, and the power is 3, so it will be a third order reaction. Now we'll go to the next one. Let us consider this same as second order reaction. The same reaction I am supposing as which order now? Second order. So if it is second order, the same equation here will be power 2 because it is second order reaction now. Okay. Now again, if I double the concentration of the reactant, from A to 2A, A to 2A, R is R, K is K, A square is A square. Now 2 square when it comes out becomes 4. So when you double the concentration of the reactant, rate is becoming 4 times, and if it happens so, it will be a second order reaction. So when you double the concentration of the reactant, rate becomes how many times? 4 times, and 4 actually means 2 square, and this power 2 indicates second order reaction. Now the same reaction I am taking it as first order reaction. So if I take the same reaction as which order now? First order, the power out here will be 1. Now again, if I double the concentration of the reactant, if I double the concentration of the what? Reactant from A to 2A, see what happens. R is R, K is K, A to the power 1 is same. Now I am just taking the power out, 2 to the power 1 means what? 2. Okay. So when you double the concentration of the reactant in first order reaction, the rate is becoming 2 times. That means when you make the concentration of the reactant increase by 2 times, the rate is also becoming 2 times, and actually 2 means 2 to the power 1, 2 means 2 to the power 1, and this power 1 means which order reaction? First order reaction. Now if I consider the same as 0 order reaction, see what happens now. If I consider the same as 0 order reaction, the power out here will be 0. The power out here will be 0. Now, if I double the concentration of the reactant from again A to 2A, I am doubling the concentration of the what? Reactant. So if you see out here, students, this is rate of reaction, this is rate constant, A to the power 0 is here. Now 2 to the power 0 means 1. Anything to the power 0 means 1. 1, no need to write. So the rate remains as it is. The rate remains same. The rate remains same to same. So on doubling the concentration of the reactant, the rate remains same. If rate R remains same, then it will be which order? 0 order reaction. Always keep it in mind. Similarly, now look out here. If you see here on doubling, it becomes 8 times means power 3. 4 times means power 2. 2 times means power 1. 2 times no change means it is which order? 0 order reaction. That only I have explained you here. So look out here now. The order of reaction whose rate become 8 times when the concentration of the reactant is increased by 2 times. So what is 8 of 2? 2 cube. So third order. So here if you increase the concentration of the reactant by 4, your rate become 4 times on increasing the concentration by 2 times. So what is 4 of 2? 2 is square. Power is 2. So second order. Now again when you increase the concentration of the reactant by 2 times, the order also become 2 times means 2 to the power 1. So it is which order? First order reaction. Now when you change the concentration of the reactant, if the rate remains same, that is which order? 0 order reaction. So I like to give you some more examples. When you double the concentration of the reactant, okay, rate became 8 times. So what is 8 of 2? 2 cube. So third order. If you double the concentration of the reactant, it becomes 4 times. What is 4 of 2? 2 is square. So second order. If you double the concentration of the reactant, the rate remains double only, that is 2 only. Power is how much? 1. So first order. When you double, no change means it is always 0 order reaction. Similarly now, when I increase the concentration of the reactant by 3 times, rate become 27 times. So what is 27 of 3? 3 cube. So it will be the third order. If you increase the concentration of the reactant by 3 times and the rate become 9 times. So 9 means 3 square. So it is second order reaction. When you increase the concentration of the reactant by 3 times, the rate also become 3 times. Means power is 1. So first order. 3 times when you increase the concentration of the reactant, no change in the rate means it is always 0 order. So students, so similarly, if I increase the concentration of the reactant by 5 times, rate becomes 125 times. And what is 125? 5 cube. So this third order again. If you increase the concentration of the reactant by 5 times, the rate become 25 times. And what is 25? 5 square, so it will be second order. If you increase the concentration of the reactant by 5 times, the rate also become 5 times, means it is first order. When you increase the concentration of the reactant by 5 times, the rate remains same, it is 0 order reaction. That means no matter you double the concentration of the reactant, triple the concentration of the reactant, you make it 5 times, 6 times, if there is no change in the rate, that will be always 0 order reaction. But if it becomes cube, that will be third order. If it becomes square, it will be second order. If it remains same, okay, without coefficient, then it will be first order, and no change means it is always 0 order reaction. Now I have given you one objective question here. When the concentration of the reactant is increased by 3 times, I repeat again, when the concentration of the reactant is increased by 3 times, the rate of reaction becomes 27 times. So the order of reaction is, you have 4 options in which you have to choose which is the correct answer. 4 options here. It is 0 order, first order, second order, or what? Third order. Now if you see out here, students, you increase the concentration by 3 times, rate is becoming 27 times. So what is 27 of 3? 27 means 3 cube, power 3. So the answer will be D, that is third order reaction. That will be third order reaction. But in order to do the rough work of this, you can manage this way. Let us consider this reaction where A gives you again product, and the rate law will be R is equals to K concentration of A. And the question is saying you to find the order, so let the order for the time being be X, because you don't know. It may be 0 for second or third. Now what the question is saying, when concentration of the reactant is increased by 3 times. Concentration of the reactant is increased by 3 times. A became 3A because the question is saying increased by 3 times. So power will be what only? X. Rate becomes 27 times. Rate becomes 27 times. Now 27 R is here. Now from here you take the number out, 3 to the power of X will come out. What remains here? K, A to the power of X remains. Now this means 27 means 3 cube R. This is your 3 to the power of X. And if you see, this means what? Compare from here. K, K. Concentration of A, X to the X is in the power. So this and this is same. Therefore, I can replace this with R. And R can be cancelled. So again, the base of the power is same. So equating the base, what will be the power? 3 is equals to X. Means the order of the reaction will be 3. Means it is a third order reaction. So you can do it directly also the way I taught you, or indirectly this way. Both the processes are correct. Now we go to the next question. When the concentration of the reactant is increased by 27 times, the rate of reaction becomes 3 times. The order of reaction is, again you have 4 options. So if you go with my previous concept, what many students will do is, here is 3 times, again here is 27, and what is 27 of 3? Cube. So they will tick it in D, again the third order reaction, which is wrong. Actually the answer is 1/3 order of reaction. The answer is 1/3. So that, because earlier I said you, order can also be in fraction, but does not come under the type. Order is 0 for second, third, but order can be also in fraction. So the answer for this is fraction order, that is 1/3. Okay, now since if you do directly, you may land up answer with third order, but it is not third, it is which order? 1/3. So rough work will be better to be done to get the exact answer. So for this reaction, again I am doing here is A gives you what? Product, we don't know the order, and the rate equation be R is equals to K. A is the reactant, order we don't know, let it be what? X. Now what the question is saying, concentration of the reactant is increased by 27 times, means A will become 27A. Okay, that time the rate becomes how much? 3 times. So when the concentration of the reactant becomes 27 times, rate becomes how much? 3 times. Now here again 27 to the power x, you take it out. What remains inside is this much. Okay. Now 3r is 3r, 27x is 27x. Now look out here again. This means this, which means r. So I'll substitute this with whom? R. R and r again will get cancel. So now here left is 3 to the power 1. And this means 27 means 3 cube. Again equating the base, what we get is 1 is equals to 3x. We get, so therefore x will become 1 upon 3. So this time the order will be fraction, that is 1/3. That will be what? 1/3. So in the previous question and this question look same. The previous question and this question look same because the question says 3 times and 27 times. So both the answer they may think as a third order reaction. Now student, how to eradicate your confusion? Pay attention. If the rate of reaction is more as compared to the increase in the concentration of the reactant, then order will be in whole number and the answer for this is third order. Whereas if the rate of reaction is less as compared to the increase in the concentration of the reactant, then the order will be fraction, will be in fraction. So the answer will be for this is 1/3. Now now we are going to do is unit of rate constant K for different order of reaction. So just now I have said you there are 4 orders of reaction, 0, 1st, 2nd, 3rd. Order can also be in fraction. Now I am going to teach you how to find the unit of rate constant K for different orders of reaction. But to find the units of rate constant for different order of reaction, you need to remember these 2 notes. Let us see what is that now. Whenever you find unit of rate constant K, students, first of all you need to know the unit of rate of reaction, that is small r. I repeat again, to find the unit of rate constant K, you need to remember the unit of r. And in my very first class of this chapter I have said you that unit of rate of reaction varies from physical states of matter. So unit of rate of reaction for solid and liquid, reactant and product is mole liter inverse, second inverse, or mole decimeter cube inverse, or second inverse, or molarity second inverse. This M stands for molarity, which is the unit of concentration, which you have learned in lower class. Okay. Now similarly, to find the unit of rate constant for gas, you need to know the unit of rate of reaction for gaseous, reactant and product, and the unit is atmosphere second inverse, and the unit is atmosphere second inverse. So students, if you know the unit of rate of reaction, that is small r, you can find the unit of rate constant, that is K. So do remember the unit of rate of reaction for solid, liquid and gas, that is for r. Then only you can find the unit of rate constant, that is K. Okay, let A gives you product, I have mentioned, and this supposition is for all the different orders of reaction, students. So usually there are 4 types of order of reaction. So I have written a type of order of reaction, that is 0 order, 1st order, 2nd order and 3rd order reaction. Okay, and the first column you can see is rate equation, then unit of rate constant K for solid, liquid, reactant and product I have written, and in the last one it is written unit of rate constant for gaseous, reactant and what? Product. So let us go with the first of all 0 order reaction, student. Let A gives you product be a 0 order reaction, then the rate equation will be R is equals to K A to the power of 0. Why 0? Because it is 0 order reaction. So anything to the power of 0 is 1, so R is equals to K. Means for 0 order reaction, whatever is the unit of rate of reaction, the same unit will be for rate constant. Whatever is the unit of R, that will be the unit of K for 0 order reaction. So as I said you earlier, the unit of R for solid, liquid is mole liter inverse second inverse, or molarity decimeter cube inverse second inverse, or molarity second inverse. Actually these all are the unit of whose? R. But since R and K is equal here, so the unit of K will be also same. Similarly, the unit of R for gas is atmosphere second inverse, and similarly R and K is equal. Therefore, the unit of K will be also same, that is atmosphere second inverse for gas. So, do remember students, for zero order reaction, the unit of R and K will be same for solid liquid as well as for gas. Now, we go to the first order reaction. So, if I consider the same reaction where A gives you product as a first order reaction, then the rate equation will be R is equals to K A to the power of 1, which we can rewrite this way, R is equals to K A to concentration of A. Now, bring this A down. So, K will be equal to R upon concentration of A. Now, this I am writing here, students, to make you understand. So, you got K is equals to R upon concentration of A. Unit of R for solid liquid is mole liter inverse second inverse, and concentration unit is mole liter inverse. So, mole liter inverse will get cancelled. So, the unit will be second inverse. So, the unit of rate constant for solid liquid, okay, is second inverse. Similarly, now for gaseous reactant and product, for first order reaction, R is equals to, R will remain as R, but instead of concentration, we write pressure. I repeat again, for solid liquid, we write concentration, but for gas, we write pressure of A. Again, the unit of R for gas is atmosphere second inverse, and pressure unit is atmosphere. So, atmosphere will get cancelled and the unit will be second inverse. So, do remember the unit of K for solid liquid and gas will be same for first order reaction. So, you can see out here now. So, mole liter inverse will get cancelled. So, second inverse remains, which is here. Similarly, for gas, instead of concentration, we write pressure. So, atmosphere and atmosphere will get cancelled, and what remains is second inverse. So, do remember, for first order reaction, the unit of K is same for solid, liquid and gas, and that is second inverse. And second inverse means actually time inverse. So, the unit of first order reaction can be second inverse, can be minute inverse, can be hour inverse, can be year inverse, means in general time inverse. So, whose unit of rate, whose unit is time inverse for first order reaction? So, answer is what? First order reaction. I repeat again, the unit of rate constant is time inverse for which order reaction? So, the answer is first order reaction. Now, we go to the second order reaction. Okay. For second order reaction, again I am supposing the same equation. Let A gives you product is a which order reaction? Second order reaction. So, R is equals to K, concentration of A to the power 2 by 2, because it is second order. Now, when you take this A square down, it will be K is equals to R upon A square, R upon A square. Now, how to solve? Let us see out here now. So, for second order reaction, you got like this, K is equals to R, concentration of A square. The unit of R for solid liquid is mole liter inverse second inverse, and for concentration is mole liter inverse. But since it is square, so it will be whole square. So, mole liter inverse will get cancelled with 1. Now, what remains here is second inverse is up, down is here mole liter inverse. So, as it goes up, it will become mole inverse, liter inverse goes up, becomes liter second inverse. So, this is the unit of K for solid and liquid for second order reaction. So, similarly for gaseous reactant or product, what will be the expression for second order? So, R will remain as R. Instead of concentration of A, we write pressure of A, and since it is for second order, so we write power 2. So, the unit of R for gas is atmosphere second inverse, and that for pressure is atmosphere, and because of the square, I am writing here square. So, atmosphere and atmosphere will get cancelled, one each. So, one atmosphere which is left goes up, become atmosphere inverse, and second inverse is up only. So, the unit become atmosphere inverse second inverse. So, students, for second order reaction, the unit of rate constant for solid liquid will be mole inverse, liter second inverse, and for gas it will be atmosphere inverse and second inverse. Now, we go with the third one. For third order reaction, again I am considering the same reaction. Let A gives you what? Product, be a third order reaction, then the rate equation will be R is equals to K, A to the power of 3. Again, if you bring this A cube down, so K will be equal to R upon A cube. And from here again we are going to find the unit of rate constant. Now, since I am considering it as a which reaction? Third order. So, the power out here will be 3 now. If it is solid liquid, the unit of rate will be mole liter inverse second inverse, and concentration unit will be mole liter inverse whole cube. So this will get cancelled with this, 2 will remain. Now see here how to bring it up. Now if you see out here, we have mole square. So mole square goes up, become mole inverse square. Liter minus 1 into 2 is minus 2. Minus 2 goes up, become positive 2. Second inverse is up only, and this will be the unit of rate constant for solid liquid for third order reaction. So similarly, how to find for gaseous reactant and product? If the reactant and product are gaseous state, instead of concentration we have to write pressure. And since it is third order, so I'll write power 3 here again. For gas, unit of rate is atmosphere second inverse, and for pressure it will be atmosphere whole cube because of this power 3. So atmosphere will get cancelled here, so atmosphere to the power 2 remains, and if atmosphere to the power 2 goes up, become atmosphere minus 2 inverse 2, and what is left here? Second inverse. And this is the unit of rate constant for gaseous reactant and product if it is third order reaction, which I have shown you here, students. So the unit of rate constant for solid liquid will be mole inverse liters, mole inverse 2 liter square second inverse for third order, and for your gaseous reactant and product, the unit will be atmosphere inverse 2 second inverse. This table you need to learn how to derive, students, but nothing to mug up out here. Now I am giving you randomly one question here. Okay, no need to mug this all. I am giving randomly one question. Suppose my question is this one. Find the units of rate constant. Find the unit of rate constant for second order reaction. Suppose if I give you this question, second order what? Reaction. Now how to approach this question? First you suppose a general reaction. So let A gives you product, B a second order reaction. Let A gives you product, B a second order reaction, I am supposing. So therefore what will be the rate equation then? Rate equation will be R is equals to K. You have to write always rate of reaction, rate constant. Then concentration of reactant. Who is the reactant here? A. Since I am supposing it as which order? Second order. So write power 2. Therefore from here rate constant K will be what? R upon concentration of A square. And you know that the unit of rate for solid liquid is this much. And for concentration is mole liter inverse whole square. So this and this will get cancelled. Now if mole goes up, become mole inverse. If liter inverse goes up, become liter, and second inverse is up only. And this will be the unit of rate constant for second order reaction for solid and liquid reactant and product. So similarly, since it is mentioned here units, so you need to find for gas also. For gas, what will be the expression? This R will remain as R, but instead of concentration, what to put? Pressure of A square, and the gas R unit is atmosphere second inverse, pressure unit is atmosphere square, so this and this will get cancelled. So as atmosphere goes up, become atmosphere inverse second inverse, and this will be the unit of rate constant for gas. So this question is related to which order, student? Second order. If the same question comes to you to find the units for third order reaction, suppose the same reaction as third order and write here power 3. Then you can solve likewise. Similarly for first order, again suppose the same reaction as first order, write the power 1 and proceed further, you get the answer. If they consider for 0 order, again you suppose the same reaction as 0 order, put the power 0 and solve it and get the answer. So this is how you can find the unit of rate constant for different order of reaction. But the main thing out here you need to note is these 2 points, okay, from where objective question can come. If you see, the unit of rate constant for solid, liquid and gas is different for third order, is different for second order, is different for 0 order. But if you see for first order, it's same. Second inverse means time inverse, minute inverse, hour inverse, year inverse, like that. So from here I like to make one question for you. Name the order of reaction. Name the order of reaction whose unit of rate constant K is same for all 3 states of matter, means solid, liquid and gas. So you can see here whose answer will be first order reaction, because for first order reaction the unit of K is same for solid, liquid and gas, that is all three states of matter. This is one of the objective question which has come mostly in ISC, and the unit will be second inverse, minute inverse you can say, and the dimension will be time inverse. Now another objective question may be asked from here is this one: for which order reaction the unit of rate of reaction and rate constant will be same? For which order reaction the unit of rate of reaction and rate constant will be same, and from this expression we can say it is zero order reaction. So remember two objective question from here: for which order of reaction the unit of K is same for all three states of matter, that is solid, liquid, gas. The answer is first order reaction, unit is second inverse and dimension is time inverse. And for which order reaction the unit of rate of reaction R and rate constant K is same, from the expression you can say it is zero order reaction. So this is my objective question to you now. Name the order of reaction whose rate of reaction small r and rate constant K is same. That means the unit of R and K is same, so the answer is zero order reaction. Next, name the order of reaction whose rate constant K unit is same for all three states of matter, means just the unit of K is same for all three states of matter, solid, liquid, gas. So the answer is first order reaction. Okay, now we will see this part: determination of order of reaction from the given value of rate constant. And this may come in competitive exam also, students. It comes in ISC board exam also in an objective. Okay students, so see here now how to solve this. Whenever the question says you to determine the order from the value of rate constant K, what are the things to be noted down by you all? Note number 1, 2, 3, 4. So whenever the rate constant value is given from which you have to determine the order, you need to remember these 4 points. Number 1, if the unit, okay, if in the unit liter is given, forget about the value of rate constant, focus on unit. Forget about the value, just focus on unit. If in the unit liter is given, students, then what you have to do is you just add 1 to the power of liter to find the order. Similarly, if in the unit atmosphere is given, subtract 1 to the power of atmosphere to get the order. And if in the unit decimeter dm is given, then first convert it to liter, then add 1 to the power of liter to find the order. In the last part, if in the unit only time inverse is given, then it will be always first order, because first order is time inverse. Okay, so I repeat again, whenever you have to find order from the value of rate constant, do remember students, you don't have to see the value, you will just see the unit, and in the unit if liter is there, add 1 to the power to find the order. If atmosphere is given, subtract 1 to the power to find the order. If decimeter cube is given, convert it to liter first, then add 1 to the power of the liter to find the order. But if in the unit only time inverse is present, that will be always first order reaction. Let us see some example of it now. So you can see, state the order of reaction from the following value of rate constant, and these are the options for you. Now see in the first one, rate constant is given 3.0 into 10 to the power minus 4. I repeat again, we have nothing to do with this value, students. You just have to focus on unit. Okay, many of them they derive the unit, then they give the answer, but it is the shortcut way to remember now. So in the unit, do you see atmosphere, decimeter cube or liter? It is clearly visible, you see liter here. And what is the power of it? 1. Power of it is how much? 1. So add 1, so it becomes 2. So this is second order reaction. Similarly, in this number 2 question, what is the power of the liter? Minus 1, add 1, 0. So therefore it is zero order reaction. In the third one, what is the power of the liter? 2, add 1. So it is third order reaction. Now in this, there is no liter, there is no atmosphere, there is no decimeter cube. And second inverse means time inverse. Time inverse means first order. Minute inverse means time inverse, so first order reaction. Hour inverse means time inverse, first order reaction. Year inverse also means time inverse, so it will be first order. So 4, 5, 6, 7 answer will be first order reaction. Number 8. Now here atmosphere is given. So if atmosphere is given, you have to subtract 1. So first see what is the power of the atmosphere. Minus 1. Subtract 1. Minus 1 makes it minus 2. But don't say minus. So 2 means second order. Minus 2 is the power of atmosphere. Subtract 1. Minus 2 minus 1 makes it minus 3. But don't say minus. So 3 means third order reaction. What is the power of the atmosphere here? Nothing is given, means power is 1. Subtract 1. So it's 0 order reaction. This is how we determine if atmosphere is given. Now decimeter cube. If you see out here, dm cube, dm inverse cube, dm to the power 6 is given. Now how to do when decimeter cube is given? So always remember, first you have to convert into liters. So do remember, decimeter cube means liter to the power 1, decimeter 6 means liter to the power 2, and decimeter inverse cube means liter inverse 1. This is the relation between decimeter cube and liter. Now if you see in the number 11 question, what is here? Decimeter cube. So decimeter cube means liter to the power 1. Now add 1, it gives you 2. So it is a second order reaction. Number 12. What is the power here? Decimeter to the power minus 3 means liter to the power minus 1. Add 1. So it will be 0 order reaction. Last one, number 13. Decimeter to the power, what is mentioned here? 6. Decimeter to the power 6 means liter to the power 2. First convert to liter if decimeter cube is given. Now add 1. 3 means it is third order reaction. So student, this is how we determine the order from the value of rate constant. So I repeat again. If liter is given in the unit, add 1 to the power to find the order. If atmosphere is given, subtract 1 to the power to find the order. If decimeter cube is given, convert it to liter, then add 1 to the power to find the order. And if only time inverse is given, it will be always first order reaction. Now one objective question to you. Among the following, which is the unit of rate constant for second order reaction? Second order reaction. Now you can see here, this is time inverse, it's first order. So it is not the answer. Liter to the power 2, add 1, third order. It is not the answer. Minus 1, add 1, 0 order. It is not the answer. Now in the first option, what is the power of the liter? 1. Add 1. Power is 1, so add 1. 2. 2 means which order? Second order. Therefore, for answer for this question is number 1. Now you can see one objective question again for you is here. For the reaction H2 plus Cl2 gives 2HCl, rate constant is given there. Now you have to determine the order of the reaction. Again, if you see, forget about the reaction, forget about the value of rate constant given, just focus on the unit of rate constant. If you see the unit of rate constant, what you can observe here is liter is given and the power is of liter is minus 1. So what I said you earlier, if it is liter given, you have to add 1 to the power. So minus 1 is given, add 1, minus 1 plus 1 makes it 0. Therefore, for this question, answer is 0 order reaction, which is very simple to identify. Okay, students, in today's class of mine, I explain you about rate law, about types of order of reaction, and how to find unit of rate constant for different order of reaction, for which I give you a little bit of trick also. So in next class of mine, I'll come with the numerical problem of order of reaction. I repeat again, in my next class, we will be solving the numerical problem of order of reaction, which mostly comes in your board exam. But there are two ways of solving that. One will be in tabular form, one will be in word form. And both the forms I'm going to explain you in my next class. Be safe. Thank you very much for today.
Hi everyone, welcome back to Economics Class 12 ISC online classes. The last class I was discussing why the demand curve is downward sloping towards the right. This is a demand curve. So this is a demand curve and it is sloping downwards towards the right. It is negative sloping or inversely proportional. When the price decreases, the quantity demanded increases and vice versa. This is how a demand curve actually behaves. And in the last class, we actually explained why the demand curve is downward sloping towards the right. Why is it when the price falls, the quantity demanded increases? There were 4 reasons. The first one was the law of diminishing marginal utility, where we discuss a consumer's equilibrium is reached when mu is equal to P. So, when the price falls, the marginal utility is greater than the price. So, to make mu is equal to P, consumer's equilibrium to be reached, we have to again buy more, because marginal utility should decrease if the price decreases. So, we buy more. That is, when the price falls, we demand more. The second one was substitution effect. And the third one was the income effect. And the fourth one was several uses of commodity like electricity. So, we understood why this is downward sloping towards the right. However, the demand curve always does not slope downwards towards the right. It is not always negative. Sometimes the demand curve becomes positive sloping. Positive sloping means that if the price increases by delta P, the quantity demanded also increases. So, it does not follow the law of demand. When the price increases, the quantity demanded also increase. That means to say, when the price falls, you demand less. So, it does not follow the law of demand. So, what we come to next is exceptions to the law of demand. The law of demand sometimes does not follow and is not negatively sloped. Sometimes it is positively sloped. Positively sloped means when the price increases, the quantity demanded also increases. There are some exceptions. We are doing a few. The first one that we are doing is Giffen goods. Now let me read first. Giffen goods. Those inferior goods, low quality goods, on which the consumer spends a large part of their income, a large part of your salary you spend on your inferior goods, and the demand for which falls with a fall in the price. Your demand will fall because the price falls. So it does not behave the way the law of demand should behave. When the price falls, demand also falls. An example is given to you straight from your Frank textbook regarding maize is an inferior food item consumed largely by the poor people. As its prices fall, when the price of maize falls, what happens? Real income of the consumer obviously increases. You will have more money, you will have more purchasing power when your price increases. When the price falls, a consumer will be able to afford superior food item. That means if your real income increases because of the fall in the price, you switch over and buy superior quality goods. So when you buy or switch over to superior quality foods, what happens? The demand for the inferior food decreases. Let me explain. To understand Giffen goods, which does not follow the law of demand, it is not negatively sloping, we have to understand again what is inferior goods. What are inferior goods? Inferior goods are low priced, low quality goods. And what happens here? When the income of a consumer increases, what does he do? He will switch over from the inferior quality good to superior quality, better quality. If you are buying a very low price Chinese mobile phone and your income increases, you will buy a better quality, superior quality mobile phone. So that is how an inferior good behaves. Remember, I for inferior, I for income. So whenever you talk about inferior goods, you think of income. I for inferior, I for income. So you say when the income of a consumer rises or increases, the demand for inferior goods will decrease because the consumer will switch over to superior quality rice or any other good. And out of this inferior goods, Giffen goods is a part of inferior goods. Giffen goods is a part of inferior goods, means Giffen goods are low quality, low priced goods, because Giffen goods is a part of inferior goods. But these Giffen goods, that means this low quality goods, what happens is they do not follow the law of demand. They behave differently. So Giffen goods are inferior goods. However, what happens is, when the price of these given goods fall, then the quantity demanded also falls. What should happen? It should increase. But here it will fall. When price falls, quantity demanded also falls. It does not follow the law of demand. What exactly happens here is, given goods are inferior goods where, for example, you take an example of low quality rice. The poorer section of the people spend most of their money, most of their income, most of their salary on food, rice, low quality rice. So your major expense from your income is rice. So what happens is, when they spend large part of their income on low quality rice, and the price of this low quality rice falls, what do you think? You will think the demand for this low quality rice should increase because price falls, but it doesn't behave like that. What happens is, when the price of this low quality rice falls, for the poorer people, they switch over to superior quality rice because their real income has increased. Let's see what exactly happens. Let us say Giffin's good, one of the Giffin's good, which is an inferior low quality good, let us say it's rice. Low price, low quality rice. Russian rice, low quality rice. Okay, price is cheap. And the poorer people spend large part, most of their money on rice. So what happens is, let us say the rice, low price, low quality. Low quality means inferior. Inferior good. What happens here is, let us say the price of this low quality rice is, say, 20 rupees per kg. And he buys 10 kgs. So his expenses is 200 rupees. Okay. Now, this rice, price of this rice is no longer 20 rupees. Let us say now it is just 10 rupees per kg. Now, when you think it is 10 rupees per kg, when the price is cheap, less, you will think that the demand should increase. But actually, demand will not increase, demand will decrease when the price is cheaper. Why? Because when the price is cheaper, what happens is, his real income is increasing. He will probably consume, let us say, let's make it say 8 kgs, 6 kgs, 5 kgs. See, he was consuming 10 kgs, now he is going to consume 5 kgs. When the price falls, the quantity demanded decreased. Does not follow the law of demand. How much has he spent? Only 50 rupees. His consumption should be 10 kgs, but he is consuming only 5 kgs. What will he do? The rest 5 kgs, he'll go for a superior quality. He will buy superior quality rice. The remaining 5 kgs, let us say the price is superior quality rice, so let's say it is around about 30 rupees. This superior quality rice is 30 rupees per kg. He will switch over from the low quality rice to superior quality rice, and he buys 5 kg of the superior quality rice and spends 150 rupees. His expenditure is same, but his demand for the low quality Giffin's good falls. What it means to say is, when the price of the Giffen good falls, the demand will also fall, not following the law of demand. Why? Because the poorer section of the people who spend large part of their income, when the price falls, when their real income increases, they will switch over to superior quality rice. What happens to the demand for inferior quality rice? It will decrease. So now you've understood what is Giffin's good. Giffin's good are inferior goods. They are part of the inferior goods, but it is those inferior goods where the poorest section spend large part of the income on that good, and when the price falls, the quantity demanded will also fall because they will switch over to another superior quality good or food. This is on Giffen's good. The next one, Snob Appeal. Here, generally in exam, they will ask you more of conspicuous consumption rather than Snob Appeal. Conspicuous consumption, basically these apply to commodities which serve as status symbol, social prestige, display of wealth, etc., where other people envy their possession. An example I've given you is platinum. The higher the price of platinum, the more will be the demand by the rich. So, conspicuous consumption is basically for status symbol, a prestige to display your wealth. If a good is more expensive, you will see especially celebrities, film stars. I remember a long time back when Priyanka Chopra came up to some program, specifically she was wearing platinum. The idea is not diamond, platinum, all above the rest, showing that she is rich, successful. So what happens is, when a good is more expensive, especially for the rich people, when it's more expensive, they want to buy more of that. The price is increasing, they want to buy more because it is a display of wealth. It is a status symbol for them to show that the price is very high and I can afford that. So that is Snob Appeal and conspicuous consumption. A word from here I'd like to add is, there is something like conspicuous consumption for necessity goods. Conspicuous consumption for necessity good is something extra I want to give you. For example, today you will see around town that the trend is the young girls, women, they want to learn how to drive a scooty. It is kind of a, yes, practical also, but a status symbol also that you drive a scooty. So it becomes a status symbol, social prestige that you can. So what happens? Even if the price of the scooties go up, the demand will continue. So this is called conspicuous necessity consumption. Mobile phone is a necessity, but when somebody doesn't have a mobile phone, you will not be in the society. You should have a mobile phone. So it's a conspicuous to show around that you have a phone, and it is a necessity. That is something extra. The next one, expectation regarding future prices. So you expect the prices to rise in the future. Please be careful here. Here you will not say the price is constant, it hasn't changed, and in future it will change, is wrong. Otherwise you cannot explain when the price remains same, you cannot explain when there is no change in the price, you cannot explain what happens to the quantity demanded. And very importantly, you have to say, if the price of a commodity is rising, that means the price of the commodity is already increasing. It is increasing and is likely to rise further. In future it is going to rise again. It is rising now only, and in future it's going to rise more. What will you do? People will buy immediately so that they will avoid the pinch. That means they don't want to pay more in a later or in future stage. So they buy now. That is, when the price of a commodity rises, consumers will demand more. Price increase, demand also increases. Similarly, when the price falls, price is already falling and we know that it's going to fall, consumers know it's going to continue falling. That means you wait, you will postpone consumption, you will not buy, you will wait for the price to continue to fall. So what happens? Demand will decrease when the price falls, does not follow the law of demand. The next thing is Veblen effect. Here I've written Veblen effect. Some books give you price quality or Veblen effect or price quality effect. Now here I will read, consumers sometimes take prices as an index of quality. More goods may be demanded at higher price. I put on one example here. Premium petrol is priced higher than ordinary petrol, which is almost the same quality. We don't know, we don't test it. So it's almost the same quality. Some people buy more of premium petrol. A typical example is when you drive down to Siliguri, they have two options. You want premium petrol or petrol. Then you think, premium petrol, you pay a little bit more, 1 rupee or something more. But you think that premium petrol is better quality. Why? Because the price is slightly higher, it must be a little bit better quality. Another one that is given in your books is Supreme Lux and Lux. There are two types of Lux soap, let's say. So when you see Supreme Lux, slightly expensive, a little bit more than the normal Lux, you will feel that is better quality because the price is higher. So goods which are slightly higher priced, comparatively you will feel that it is better quality. It may be better quality or not, but because the price is higher, the demand for that good will increase. So what I did now was, number one was, Giffen's good does not follow the law of demand. 2. Snob Appeal, conspicuous consumption, status symbol. Higher the price, the rich will buy more. Then we also did expectations regarding future price. In this, you must be careful. You must say the price is rising and it will continue to rise in future. So consumers feel that they better buy now, otherwise it will be more expensive. So when the price rises, demand also rises. And the last one we did was Veblen effect. Veblen effect, quality and price relationship. You will feel, a consumer feels that if the price of a good is slightly more, that means it must be better quality and the demand for that good will be more when the price is more. So these were the 4 factors which actually does not follow the law of demand, or it means it is positively sloping. Otherwise, demand curve should be negative sloping. So all that is done. The next thing I will give you in short is regarding how the demand curve moves. Let's have a look. The topic is movement and shift in the demand curve. How does the demand curve shift or move? In movement, what happens is, this is your demand curve with your price and your quantity demanded. Movement means that from here you might move here. Movement along the same demand curve. The demand curve will not shift, but there is a movement along the same demand curve. For example, say here, when the price falls, from here the price falls and you are here. So when the price falls, you will find that quantity demanded will increase. You were here at A, you move at B. Or if you are at B, you move at A. Whenever you move, when the price falls, there is increase in the quantity demanded, you move from A to B. When the price increases, then there will be decrease in the quantity demanded, because the law of demand follows that. And you were here at the beginning, at B, you move to A. This is movement along the same demand curve, and notice there is a change in the price. So in movement, I will discuss change in the price, but all the other factors remaining constant, like your income does not change, price of the related good do not change, other factors which affect demand do not change, only the price changes. When there is a change in the price, then there is movement along the same demand curve DD. When price increases, what happens? There is decrease in the quantity demanded, you move from B to A. It is called contraction. If price falls, what will happen to the quantity demanded? It will increase in quantity demanded, you move from A to B. This is known as extension. You'll understand contraction and extension. Change in the price, other factors remaining constant. Now shift. What is this shift? This is the demand curve, dd. There is no movement along the same demand curve because here the price remains constant. Price will not change. Price will remain same, but the other factors change. What other factors? Let us say income of the consumer increases. What will happen if your income increases? Obviously, you will say there's increase in demand. So when there is an increase in demand and your price is same, but you have to show an increase in demand, the whole demand curve has to shift. The demand curve will shift rightwards, rightwards, upwards, rightwards, upwards. Price same. This was your original quantity. Now the price is same. Your demand curve shifts rightwards, upwards to Q dash. The change is delta Q. You'll notice that when the price is same, but other factors change, like income of the consumer increases. When income of the consumer increases, there is increase in demand. There is no movement along the same demand curve because the price is constant. What happens when the other factors like income change? The demand curve will shift. Here, when income increases, the demand curve shifts rightwards, upwards, and there is increase in demand. Another thing you will see when I explain to you is in movement, you will have to say increase in the quantity demanded or decrease in the quantity demanded. In shift, you have to say increase in demand and increase and decrease in demand, not quantity demanded. When there's a change in the price only, you will say the increase or decrease in the quantity demanded. When other factors change, then you will say increase in demand or decrease in demand. I will just explain to you the first one. So I am going to teach you what is contraction, what is extension in detail. Okay. Movement along the same demand curve. We will do extension. Extension means increase in quantity demanded. Increase in the quantity demanded. Here, movement means the demand curve will not shift. DD, this is price, this is quantity demanded. X-axis origin, you must write origin, y-axis, x-axis. Okay, so extension. Extension means increase in quantity demanded. If you want to increase in the quantity demanded, what should happen to the price? Price should fall. Price was P, now it is P1. Delta P is the change. Price falling. You are at Q, now Q1. Delta Q. So, earlier you were here at A. Price, quantity at A. Price decreased. There was increase in the quantity demanded. So, your final point is B. This is extension. What happens? Number one, there is increase in price. Other factors remaining constant. Price will increase, but other factors like income, price of related goods, government policy remains unchanged. Secondly, you will see movement along same DD demand curve. From point A to point B. So this is extension or increase in the quantity demanded, where when the price falls, there is increase in the quantity demanded from point A to B along the same demand curve. Price has decreased. When price decreases and other factors remaining constant, what happens? There is an increase in the quantity demanded. So this is the first one, extension. I am going to touch up to here only today. You need to go through and have a look at extension. Once you understand what's happening here, then the whole movement and shift will be explained. First, you need to go through this. Once you're ready, ready and you've understood this, then only I can explain to you movement and shift as a whole together. That is all for today. Thank you so much. Have a nice day. See you in the next episode. Thank you so much.
Hello wonderful people. Welcome back to the next episode of the online class. Okay, we are with computer application or computer science. For ISC it is computer science. So last day we were talking about Boolean algebra, so we continue with Boolean algebra. Today we will be dealing with the truth table. Fine? We will be dealing with truth table. Now we had this expression, this is Boolean expression last class also. In last class we had drawn the Boolean gate, logic circuit or logic diagram. Today we will draw the truth table for this. Fine? Now we know that A, B, C, these are called the Boolean variables or Boolean literals or Boolean inputs. So if you look at this expression, we have got three Boolean literals, A, B and C. So when we speak of A, B and C, three literals, so number of combinations will be 2 to the power 3, that is 8. So 8 combinations we require in the truth table. Fine? So let's proceed. So A, B, C, the three literals, and the 8 combinations, the slots for 8 combinations. Fine? The first one, slot A, we start with 0, 0, 0, 0, 1, 1, 1, 1. If there are 8 combinations, remember half will be zeros, half will be 1 for each of the literals. The one which is on the extreme left are the three literals, will have 4 zeros and 4 1, that is half of 8, 4 zeros, 4 1s. Fine? Next we move on to the second literal, the B. In B we will have 2 zeros, 2 1s, 2 zeros, 2 1s. So 0 0, 1 1, 0 0, 1 1. Fine? And the literal on the extreme right will have alternating zeros and 1. So C will be 0 1, 0 1, 0 1, 0 1. Fine? Now if you look at these combinations, this each one, there is no repetition. 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. So there is no repetition of any of the combinations. Fine? So for the three literals, the truth table is ready. Now when you are solving this expression, the first thing that you need to solve is the not, the negation. Okay? Not A, the reverse of A. Not A has to be solved first. So A is here. So not of this. So let's draw it up. A complement. Fine. So you see here, A is 0. The reverse is 1. Again 0, 1. 0 is becoming 1. So here A was 4 zeros. There we have got 4 1s. The reverse of 0 is 1. Similarly, the next 4, here we had got 1. Not A will become zeros. So 0, 0, 0, 0. So A complement becomes 1, 1, 1, 1, 0, 0, 0, 0. Fine? So now we have solved the truth table, or we have drawn the truth table for A complement. Now whatever is in the bracket, this has to be solved. That is C dot A complement. Dot means AND get. So C ANDed with A complement. Fine. So let's draw the table for this. C dot A complement. Okay, C is here. This column is C. And A complement is this. So we have to deal with these two columns, this and this. This we don't require right now. Okay? So C dot A complement. In case of dot, dot means AND get. AND get means if both are 1, then only the output will be 1. In all other case, it will be 0. So first row, 0, 1 will be 0. Next one we have got both 1, 1, 1. So it becomes 1. Third one is again 0, 1. So 0. Fourth one is 1, 1. So it is 1. Next one is 0. Next again 0, 0 and 0. So only in this row and this row, these two rows, we have got both 1s. So the output is 1, 1, 1. Rest all are 0. So we have solved C dot A complement. Now we have got the OR gate between A, B and C dot A complement. We can solve it in one go because it is the same gate. The OR gate. So let's write it down. Fine. So A plus B plus C dot A complement. Now A is here, A and B. We have got A plus B. So A is in this column, B is in this column. And just now we have solved C dot A complement. So it is here. So these three columns, first, second, and this one, last one. Fine. The middle two we don't need. We need to concentrate on this first, second, and fifth. Right? Now we are using the OR gate, plus, the OR gate. OR gate means if any of the input is 1 in a particular row, if any input or any variable is 1, the output becomes 1. Only when all the inputs are 0, the output is 0. Right? So first row, 0, 0, 0. So output will be 0. Next row, 0, 0, we have got 1. So 0, 0, 1 will be 1. As I said, if any input in this row is 1, the output will be 1. Next what we have got, 0, 1, 0. So there is 1 here. So output becomes 1. In the next one also, there is a 1 here, there is a 1 here. So 0, 1, 1 is 1. Next one, 1, 0, 0 is 1. Next we have got 1, 0, 0 is 1. Next we have got 1, 1, 0. So there are two 1s. So it is 1. And the last row, 1, 1, 0 is also 1. So we have got 0, 1, 1, 1, 1, 1. Except for the first row, all are 1. Because in the first row we have got 0, 0, 0, 0. So it is 0. In all other case, we have got, in one of the other input, we have got 1. So the output is 1. So this is your final output. So if you have an expression A plus B plus C dot A complement, truth table, the final output is 0, 1, 1, 1, 1, 1, 1, 1. That is 1, 0 and 7 1s. So this is how you develop the truth table for a given expression. Got it? Good. We move on to the next one. Okay, before this, remember this is the logic diagram which we had solved in the previous episode. For the same expression, this was the logic diagram. We have already solved it. I'm just showing you. Now we move on to the next expression. Okay, we move on to the next expression. The Boolean expression, we have got x complement plus xy dot y complement plus xy equals to xy plus x complement y complement. That is, we need to prove this left hand side is equal to the right hand side expression. Left hand side expression is equal to the right hand side expression through the use of truth table. Okay, through the use of truth table. So if you look at this expression, how many literals are you getting? So if you look at the expression, we have got two different literals, x and y. Only x and y, two different literals. So two literals means to the power 2, that is 4 combination. Only 4 combinations you need. Fine. So let's continue with this. Let's draw the truth table. Let's first think about the left hand side. Left hand side we will need around, I think, 1, 2, 3, 4, 8 columns, most probably. Let's fill this up. First we have got x and y. Even though in the expression we have got x complement, first we have to take the two literals, x and y. Okay? Remember, half will be zeros, half will be 1. So x is 0, 0, 1, 1. Y will be 0, 1, 0, 1. Fine? So two literals, x and y, and the combinations of the zeros and 1. Next we solve x complement. Remember, we need to solve the complement first. So x complement. X complement is the reverse of x, the complement of x. So zeros will become 1, ones will become 0. So we have got 1, 1, 0, 0. If you look, x was 0, 0, 1, 1. X complement becomes 1, 1, 0, 0. Fine. Next is xy. Xy means x dot y. X dot y is AND get. So x and y. So xy. That means between x and y we have to use the AND get. In case of AND get, remember, only when both the literals are 1, the output will be 1. In all other case, it will be 0. So 0, 0 is 0. Next one is 0, 1 is 0. 1, 0 is 0. And finally, last one, 1, 1 is 1. So only in this last row we got both as 1. So output is 1. So xy is 0, 0, 0, 1. Next, we join this one with the OR get. This portion we solve. We solve this one. X complement plus xy. Plus is the OR get. So we are dealing with these two columns. This we don't need now. We need only this column, x complement, and this column, xy complement. We are using the OR get. In case of OR, if any of the literal is 1, the output will be 1. Only when both the literals are 0, the output will be 0. Fine. So first one, 1, 0, 1. 1, 0 is again 1. 0, 0 is 0. And finally we got 0, 1 is 1. So x complement plus xy is 1, 1, 0, 1. Okay? So this portion is solved. Now we come to this one. Because we have placed them within bracket, so whatever is within bracket will be solved first. Again, within the bracket, we have got y complement. So y complement needs to be solved first. So y complement. Y is here. So complement of y, that means 0 will become 1, 1 will become 0. So 0 becomes 1, then 1 becomes 0, 0 becomes 1, 1 becomes 0. So y was 0, 1, 0, 1. Y complement is 1, 0, 1, 0. Fine. Xy we have already solved here. That xy we have solved here. So we don't need to write it again. Now we need to combine this. Y complement plus xy. Y complement plus xy. Y complement is here. Xy is this column. So this column and this column we combine using the OR get. So 0, 1 will be 1, 0, 0 is 0, 0, 1 is 1, 1, 0 is 1. Only where both the literals are 0, the output is 0. In all other case, it will be 1. So we have solved this, we have solved this. Now we have to join them using the dot operator or the AND operator. Now, when you are solving in a paper, if the space is not enough to fit this whole expression, what you can do is, you can give a separate literal for a particular part of the expression or the part of the table. Like this column where we have solved x complement plus xy, I am giving the new alias that's called A. Okay. And this one, the next one, y complement plus xy as b. So this column as a, this column as b. Since this whole expression will not fit in my table, I have shortened it out by giving this columns, this expression as a, representing this expression as b. So here this is a, this is b. So a dot b. So now I write in the column header a dot b, where a is x complement plus xy, b is y complement plus xy. Okay. So now we will use the AND get between these two columns. So first row 1 1 is 1, 1 0 will be 0, 0 1 is also 0, and finally the last row 1 1 is 1. So this expression ANDed with this expression, you get this output 1 0 0 1. Fine. So now we have solved left hand side part of the expression. So ultimately for the left hand side we have got 1 0 0 1. Now we move on to the right hand side of the expression, this portion, right hand side of the expression, xy plus x complement y complement. First is xy. We already have solved xy here, so we'll just write the same thing there. We copy it 0 0 0 1. xy is 0 0 0 1, they are also 0 0 0 1. Next we have got x complement y complement. X complement y complement, that is x complement dot y complement, x complement and y complement, dot represent and. Fine. Where is x complement? X complement is this column, y complement is this column. So x complement, y complement, between these two we will use the AND get. So first one is 1 and 1. So x complement y complement is 1. Next one is 1 is here, 0 is here. So it is 0. We are using AND get. Remember, when both the complements are 1, when both the literals are 1, only then the output will be 1. In all other case, it will be 0. Third row, 0, and here there is 1. So 1 is 0, so it becomes 0. Last one, both are 0, so it is 0. So x complement, y complement, we have got 1 0 0 0. Okay. So we know this. We have the output of this part of the expression, we have the output of this part of the expression. Now we need to combine them using the OR gate. Okay. So xy plus x complement y complement. Xy, remember this column is xy, x complement y complement is here. So we are using these two columns only. So we are using OR gate. 0 1 will be 1. 0 0 is 0. Again 0 0 is 0. And 1 0 is 1. So now we have got 1 0 0 1. So right hand side, when we have solved it, we have got 1 0 0 0 1. Okay. Now if you look, we have got the same output. Left hand side is 1 0 0 1, right hand side is also 1 0 0 1, the ultimate output of left hand side and right hand side. So from this you can see that they are same. So left hand side equals to right hand side. We have proved it. Okay. So this is how you solve a truth table. You may be just given a question where you need to draw the truth table for the expression, or you may be given an expression like this where you need to prove that left hand side is same as right hand side using truth table. Okay. So whichever method comes, you will be able to do it. Fine. So we'll stop here today. And as usual, thank you everyone. Stay safe and stay at home. Thank you.